Hey there, and thanks for checking out another 3D Sky video. So here we are in my humble studio, and if you haven't noticed, my lighting in here is kind of terrible. Now, I may have done some stuff to the video to make it look somewhat decent, and I've got a specific forward-facing LED light on my camera facing me so that it brightens things up a little bit. But that's really just a band-aid kind of thing. It's great for when you're out on the road, just going mobile, and you want to be able to see what you're pointing your camera at. But for some place that I intend to do a lot of filming, it's not really a great long-term fix, especially because it's battery powered and the thing dies, and then you gotta wait for it to charge. And I'm not gonna buy numerous of them to just always have one ready to go. So what I'm going to do is, I've actually had these photography, videography lights for like 6 years now. This is not the room I originally was working in when I bought them. That's why I don't already have a solution for them. This is sort of a brand new office for me. So what I'm going to do is I'm going to take these massive videography lights that work pretty well. I'm not going to light one up right now, but they work great, but they're huge. They definitely help diffuse the light, which is great, so you don't get like a one singular spot sometimes. It just helps broaden the light and how far it actually lights up your room. And they're great, except for the size, as I've mentioned. They're huge. What I want to do is I want to not have them on the floor, because they come with these floor stands, which is great for like a mobile photographer that's going around all over the place and whatnot. But when you try and put this up in your office, this, if I can undo the thing, this takes up a lot of space. You know, that's a lot of walking space, especially I'm in like maybe 100 square foot office, 120 square foot maybe. So space is a commodity for me. For now, hopefully one day I'll have a shop where I can do all this kind of stuff, but this is what I'm working with so far. But what is good is that they have these little pins onto which they attach, and they can screw down so it can lock on there and not fall off. So it's got that, and a lot of these videography, photography lights have these kind of things. I don't know how well you can see that. So it can go in this direction and then lock on, or it can go in this direction and lock on, so that's nice. It rotates like that. So what I really want to do is I want to get these up, probably one up right there, which obviously you can't see, and then one up over there, mostly in corners and just in wall space that I don't actually intend to use for the near future. Probably not attaching to a ceiling, because I have the popcorn ceiling, so I can't really easily repair that after I'm done with this room. So thought this would be another quick video for how to design something in 3D software and then 3D print something to fix a problem that you have, because 3D printing is just becoming all the rage now. Just about everybody's got one. They're incredibly affordable. Highly recommend getting one yourself, even if you're not very familiar with how they work. Nowadays, you don't have to be familiar with anything to get them to work. You can download the file I'll put up here for this, because this might work for your system if you have a similar light system. So I'm going to be putting the 3D file I'm going to show you how to make in the description. And then you can just download that and then throw it on a printer. You don't have to know anything about design or engineering. So it's a really fun hobby. It's affordable now. You can solve your own problems. There is some legislative bills coming out that might limit your ability to make things, at least things that might look like certain weapons that people don't want you making, which I don't condone making those yourself. But it's certainly going to limit the ability to design things. I mean, you have to specifically design something not to look like something that could be used to make your own weapon at home. And this also means that the government's going to be reviewing all of your data. You're reviewing your printer and just knowing things that they probably don't need to know. And the legislation hasn't passed. They're voting on it, but I guess we'll find out what's going on with that pretty soon here. So let's hope that that doesn't move forward for just privacy's sake. So before we start getting in the program, what we need to do So we need to take some measurements of what we already have. If you already have something in real life, it's great to go ahead and just model it as it is in the program so you can know how to design something around that. Well, really, we have what we want to design, part of what we want to design. This is what that thing already attaches to. We know that this is a really good design, give or take, you know, some possible minor problems that it has, but we know that it works with the system that we have. The height, the diameter, the little top part, and chamfers to keep it from sliding off. So what we really need to do is just get this main piece here, this silver piece. The black part is not necessarily important, other than just getting it away from what it's mounted to. The silver part here is really what is the most important part. I don't know if you can see that silver part very easily. So we need to figure out a way to mount that to a drywall. So we're going to need to be able to screw into the drywall, through a hole that's going to be mounted to this, and optimally go into a stud. I'm not going to mount these things unless they're in a stud. They're not super heavy lights, but why? I mean, I have the opportunity to just drill straight into a stud and it's not going to affect me. If you didn't, then I would get one of those really strong drywall anchors, but for this purpose, I'm just going to go straight into a stud. But we're going to need to know how far off the wall does this need to be so that the light can still fit on and maybe maneuver a little bit, because you want some of that maneuverability. So let's go ahead and start writing down some notes. Another thing I highly recommend to have on hand, handy dandy graph paper and a quality pencil, lead pencil, or pen. I like doing stuff in pen too. But what we're going to do is we're just going to quickly do a rough sketch of this and potentially an idea of what we want to actually model in Fusion, because it's just very easy to draw, erase, scratch something out and do something new before you actually go into here and start making a whole bunch of different solids and components and different things like that. It's best to just go ahead and sketch it out on paper. So let's take some measurements of this. I typically work in millimeters, so it's easier to get fine granularity, at least in my opinion. Things that divide by 10 are just simpler. And I mean, we could do decimal inches, but I'm sorry if you don't like that. I just much prefer to work in millimeters. So the main diameter of the shaft is about 11.5 millimeters. So I just draw a little shaft, 11.5 millimeters. Now we're going to get the height of that 11.5 millimeter shaft before those chamfers start. That's about 13. So now I know the length. Now I'm going to get the overall length from the top of the chamfer to the top of the other chamfer. Those look like 45-degree chamfers, but you never can tell exactly unless you have an angle measure, and I don't. It's about 16.75. All right, now it's mostly all that really matters. I'm going to go from the very top of this thing to the bottom of that chamfer right there. About 19 millimeters. You'll just want to notate, I mean, there is another top chamfer on there that you'll want to make sure to model. This distance down here, I don't think that really matters, but let's put it in to the hole that it's supposed to go to. Let's see if that actually does matter. It actually does, because that silver part goes down to exactly where the end of this front part hits in the bottom there. So that might matter a little bit. So let's go ahead and keep that aspect. And we also need to know the overall diameter, which will, of the top up here, and it matches this diameter down there. So let's get that measurement. It's about 14.7. And then the depth of that, it's about 4.6. All right, so I think we have all of our parts dimensioned for, at least for this part. Then we are going to have to figure out how to connect that to essentially a wall bracket. Be very simple. We might want to think about where we're going to put the light, what orientation. That way we know exactly whether we want this straight up and down like that, or do we want it sticking off the wall like that, or an angle, because this thing angles. We probably don't need it at an angle itself. I kind of want the light, I think I'd rather it hang in this orientation than to be supported in this orientation. So it's just something you want to think about. So I think it's probably going to be best to have this come off the wall at 90 degrees, perpendicular to the wall, and then latch on like that. That's what I'm going to try first, so let's see how that goes. Okay, so now that we are loaded up in Fusion 360, let's go ahead and get this basic drawing started. So I'm going to draw, because I want it going perpendicular to the wall, I'm going to go ahead and draw this on, let's see, this plane, because then I'm going to rotate it about that axis right there. So essentially what I'm going to be doing is drawing half of this, and then we're going to be rotating it. First, what I'm going to do is I'm going to change my units to millimeter. Now I'm going to be just drawing on the X plane, or top plane. Go out this far, and the total distance that we have, total height, is 19 millimeters plus 4.6 millimeters. So just going to do that like that. And then we go off the side, 14.7 divided by 2. It's nice because you can easily do math there. And we have the same down here. So let's do 7 divided by 2 again. We go up 4.6. And then we have a 45-degree angle there. So let's just go random distance in there. We've got a 13 millimeter section that we're going to have to place. Now we've got another 45-degree section coming off of here. Just a random distance. Slide this out of the way a little bit. And then we know we come down from the top here. We go down 19 minus 16.75. And right at that point, this connects. So we have that placed. So now this is starting to come together. We can go ahead and get our trim tool, trim that off, trim that off. Now I can dimension that, which we didn't measure that, but that's essentially what that would come out to. And then there's also a little 45-degree, or 135 in this instance. Oh, don't have that. Whatever. Small little chamfer up there as well. I did not specifically measure how tall or how the diameter of that top circle. It's a very small, it's unnecessary, but we'll go ahead and get it anyway, just to be as accurate as possible. It's about 13.8 diameter on that top. So what we'll do is we'll go from this point, go this way, 13.8 divided by 2. Oh, wow. Could not have gotten any closer on that just by random happenstance. Okay, so what we're going to do is we're going to make coincident with that. This is already 45 degrees, but we can go ahead and dimension that if we want to. We can trim these parts off like that, and trim that and that. And essentially, there is our piece that we're going to rotate. So we're going to finish sketch, come up to revolve. It automatically selects it because it's the only thing there. We're going to select that. Ta-da! There is our piece. That's exactly what we wanted. Go ahead and save this. Light holder wall mount. Save that. Okay, now that we have this, So now that I know, I want it to be 3 inches approximately anyway off the wall. What I can do is I can go ahead and model the wall just to have a good idea as to what all this is. So I'm going to do 3 times 5.4. That's 3 inches. We do that in construction mode so that that's not an actual line. I'm going to go back to normal mode. I'm going to go just up an arbitrary amount of distance and down. So that is the wall. Let's actually go ahead and just make a rectangle out of that. Extrude that. So now we'll have an actual wall. Symmetric. All right, now we have, it's a good idea as to how this thing is actually going to be hanging on the wall, except for it's going to be angled 90 degrees that way. That did change how far off the wall it is. So let's just go out another ½ inch. Another ½ inch. Let's see if we can. 74.2. It's exactly 2.92 inches. So yeah, may as well just go out another 0.5 inches. Now we're over 3 inches. And that's what we want. So now to connect this to the wall. So let's go ahead and design the thing that's going to be on the wall. So what I can do is I can hit P to project, click on the layer, the plane that I want to project onto, and I can draw this just to give me a good outline. Or click on all these, and that's going to give me an outline as to what that's going to look like. So we can just, don't have to connect all these, but just connect that. So now we know exactly where that's going to meet up to. We don't want to be much larger than the width of a 2x4 that's in the short direction. So 1.5 inches. So what I'm going to do is do 1.5 inches there. And then the height, let's just say for the height we'll do a total of 4 inches for the hanger. So let's just go out from the middle. How about that? 1.5 inches. Let's make that a construction line. Just click it and press X. Let's go up 2 inches. And I'll go down from here 2 inches. And then I can click R to do a rectangle, go up. There we go. Now I've got a rectangle. So this is essentially will be the plate that I'm going to screw the wall. Let's do maybe 5 millimeters. Don't join that. We're going to make a new body. Okay, now that we have that, let's put some screw holes in here. So let's press X to make a construction line. Let's go here. Actually, we don't need to do that if we're just trying to find the middle line. Just go to the triangle. Triangle means midpoint. Let's go ahead and place 2 holes. Oh, goodness. Those holes should not be construction lines. Let's select those, press X. I've got 2 holes. So I've got a screw here. I'm going to take a quick measurement across the threads. They're about 5 millimeters, a little under 5 millimeters, but I'll make the screw hole 5 millimeters in diameter. That way to make sure we can get threads all the way through that. We're going to do a third hole there. Click X. X again to turn that off. Can never be too safe with how many screws you put in something. I'm going to click D and then click that circle and click this to get a specified distance away from the edge. And we're going to go maybe 10. Doesn't have to be that far away as far as it was. I'm going to do 10 down here as well. That one is in the middle already, so we're going to leave it there. And I'm actually going to just delete that middle one. We don't want too many screw holes in our wall because that's just more putty and paint we're going to have to buy later to repair this if we ever take it down. So that looks like a good base plate. Also remove that middle one too because we're going to have to connect this to that somehow. And the best way to do that is probably through the middle right there. So I'm going to finish that sketch. I'm going to go ahead and lengthen that about 5 millimeters just to give us some more room to play with. And here's where the fun part begins, figuring out exactly how you're going to connect these two parts. So what I'm going to go ahead and do, I'm going to select those, just go ahead and get the screw holes in there. Get a slight chamfer, not super deep, maybe 2 millimeters. All right, so that looks good. And we obviously could just very easily and basically attach that, but we want this thing to be strong. We also need to make sure it stays out of the way, which there wasn't really much in the way. After you get that thing on here, everything out to here, out to this side is pretty much open for whatever we want to do. I'm thinking instead of just going a straight bar from there to there, I'm thinking something triangular to get the most amount of strength. So what we're going to do is we're going to construct, we're going to mid-plane, click both of these outer planes there. That's going to give us a plane directly through the middle of that object that we can now sketch on. I think that that's going to be the best thing to start drawing this triangle on. And we can click P, we're going to project that, and then we're going to project that. So now we have all of that to play with and actually interact with. So I'm just going to go an arbitrary distance up there, click that, escape, do the same thing down here, just arbitrary. We could go ahead and make that tangent with that. That would probably be a good idea. That little symbol right there means tangent to. So now those are essentially, well, okay. Sometimes this will happen. You'll click a line, you'll click so fast, it'll accidentally create a straight line right there, and that's not what you want to do. So I'm going to click that, just delete that, put that there, make sure that didn't happen up there. I don't know why that happens. It happens to me all the time. I guess I'm just clicking too fast. But go ahead and click D and dimension that point to that point. Oh, there we go. Make that, let's go ahead and make it 10. It's nice. Solid number, like 10. Now, these are perfectly equal now because they have been dimensioned exactly the same. As they should be. So now I've got a pretty solid structure. Any weight put here is going to go straight into there compression wise. Tension wise up here. We could even do some kind of, let's see, just click O to do an offset. We're going to offset that. Oh, why can't I select that? Guess I can only offset one at a time. Click that. This little symbol is that means it's locked into a projection. Click that, delete that, hopefully. It's not letting me delete that. Nope, that's gone. See how it's blue? If it's blue, that means it's in the sketch. If it's purple, that means it's projected from another sketch. So I'm going to select that. And hopefully find the projection symbol. I can't. So I'm just going to draw a new line. Connect that and that. Hopefully offset will do the whole thing now. All right, yeah. If we offset that like that, we can remove some of the middle, so it won't print this middle part. It'll just print this part, which should be plenty to support the weight that we're going to develop in this. So another good thing to always be thinking about and planning for with 3D printing is the orientation of the print. So this would be kind of a weird thing to try and print if we just did it like that. Oh, and keep that in mind. That would be not smart. We need to make sure that doesn't collide. But this would also be really not that great of a print to try and print in any orientation. There's going to be crazy overhangs in every which direction. So if we go back to this, we can see that this would be really difficult to get a decent print with overhangs if it was printed in this orientation. But what would be better is if this was the bottom and it printed all this up toward the top, because then it's going to capture all these angles pretty well. Even this, like, you don't need an overhang for that if it's printed in this orientation. So that's what we're going to do. But what if we were going to print this? Let's do symmetric, print it like that. Then we have a weird overhang here. Well, we're not going to do that. What we're going to do is we're going to pull that all the way back to there. We're going to pull this to about maybe, so if we go negative 33, if we pull that back like that, then we can add back the actual thickness that we want. So let's maybe do a 10 millimeter. Get some good strength there. And I don't like how far this is away from this. That doesn't need to be that far off. So what we can do is we can actually go back, change this from to a join to a new body. Then we have that body right there, move it back. Actually, just click A, and select that face, and then select that face, and it'll align that. The align tool is very handy and good to know how to use. Okay, so now that we've got a decent idea of what we're doing, or we're decently approaching our end goal, let's do a quick sanity check. Would this even make sense? Would it work on the part that we're actually wanting to attach to this? And if you look at this picture right now, probably not, because of those little thumb screws, those little winged screws. They'd probably hit this in one orientation and then hit this in the other orientation. So a quick and easy way to fix that would actually be to just put this thing further back, maybe not quite that far back. And we might have to do a test printer too. I'm going to move it back to, oh, no, that's 10 millimeters, just like that. Hopefully that'll be plenty of room. I could do some measurements, but 3D printing sometimes is just quick and dirty. Just print it, try it. If it doesn't work, redo it. Not always the most efficient way to do something, but this is likely to work. Add a fillet there just to give a little bit more strength in that direction. 5 millimeter. Maybe do another one there just to make it look good. Fillets can add some strength. So that's going to have a lot more strength than just that hard 90-degree angle. In terms of this flexing out this way, that direction, because it's just got more material there. And a circular shape is much stronger than a 90-degree angle. In fact, just to make it a little bit cooler maybe, let's go ahead and select those. Give those a little bit of a chamfer, or fillet. Yeah, that looks a lot cooler. Let's go 5. And fill out these edges just to make it look a little bit more professional. Let's do like a 2.5 on those maybe. Yeah, not too much. Ooh, yeah, let's do that one too, maybe 2.5. And then maybe fill it there and there, 2.5. Pretty much all your hard edges. Some of these are just aesthetic. But that looks like a pretty nice looking part. So we've got about 4 inches between those. Got about 1.5 inches there. So you get that right in the middle of your stud and it'll be looking real good. You've got great access to that screw hole for your screw gun as long as you have a decently long bit extender, which I always recommend having. That should be good to go. Now, something that might be a better idea is to make this to where it could be easily screwed into a stud in this orientation, being straight up and down, and then potentially also get back to normal orientation, to where that would be the orientation we're going to screw it in, and then also maybe that orientation. Obviously, you couldn't have it that long of distance, but because these lights aren't that heavy, you could probably get away with even just having one screw. This is what I'm going to do for now. I'm just saying for your purposes, in your design, you may want to make something more modular. This one is less modular because it can only really be screwed in this direction, and it looked like it's. I could obviously screw it in that other direction, but then only one screw is going into a stud, or you're only using one screw, and then people are going to look at that and be like, why does it look like that? This should be plenty strong. I do recommend, because this piece here, you're going to be clamping down onto that. I recommend using a very strong filament for something like this. Something either carbon fiber filled or maybe even something stronger like PETG, ASA, something a little bit more rigid. Some nylon would be great, probably overkill. But that's going to be receiving some crushing force, maybe some torque, because, you know, your light's going to be, the weight is going to maybe put torque on that as well. You're going to have some torque here. So in terms of infill, it's going to be a lot more expensive, but I would probably go 100% on something like this. Just because of that crushing force there, you don't want that to be degraded, because literally your entire light is connected to this right here. So if that gets crushed and hurt a little bit, well, that's not great. And if you're printing this as the bottom, so yeah, let's just go ahead and turn this in, because this is how it's going to be printed. So if it's printed like that, then your layer lines are all going like this, making this not exactly the strongest if weight is going to be going this direction. It's going to want to split those layers there. You could do this at like a 45-degree angle. It's going to get really weird trying to do that. I've not done much 3D printing at a 45-degree angle like a lot of people do. But they have success with it, so you might be able to do something like either even a 30-degree angle or something like that. But if you do this, then you're having a lot of weird overhangs. But it would make this potentially stronger, because now you have layer lines going in this direction, which might actually be worse. Because if your weight's going down this direction, it's going to actually want to pull that off. So really you'd want to do it the other direction, but that wouldn't make any sense to print this. You'd have it like going like that. That way if your weight's going this direction, your layer lines are going this direction. So it should have more protection. But that's also a crazy print. If you had a resin printer, maybe you could do something like this and it wouldn't be quite so crazy. But I think I'm just going to go with what I had done earlier. Just print it like that. Try it out, see if it works. Again, the stronger the filament you use, the stronger that's going to be there. But when in doubt, try it. If it fails, figure out another way to do it. So let's go ahead and save this as mesh. All right, there's our piece. Of course, it always loads in the wrong orientation. Let's lay that flat on that piece right there. Let's change filament to, I think that's my PLA-CF. Not sure if the carbon fiber will really help with strength in this, but we're going to try it anyway because I haven't used it in a long time. Got the right settings. So I am going to go pretty low on the layer height standard settings, because the smaller the layers are, the better the layer adhesion should be, if I'm not mistaken, especially when you're having weight suspended. The smaller those layers are, the better they should be adhered to each other. I guess we're going to find out. So I'm going to also go to not support others. Wait, no, quality. Whatever infill is. Where is that? Strength? Strength. All right, sparse infill density. Going to go all the way up to 100, which is going to make this use a lot of plastic and take probably forever to print. Let's go ahead and slice that. 2 hours. It's not bad. 73 grams of filament. It's quite a bit. All right, let's risk it for the biscuit. All right, so I did decide to change the layer heights. I'm doing the system preset 0.2 strength, which has extra wall loops and higher infill, but I'm still doing 100% infill, and that did shrink my print time to about 1 hour and 42, so quite a bit shorter. I'm going to try that out. If it doesn't work, well, I guess we'll have to try something else, but this will probably be just fine. So without further ado, let's make sure that okay, so here we are after having the print finished, and wow, I don't usually print things in 100%, but man, this thing is stout. I mean, goodness gracious, like I tried flexing it as much as I could without really trying to break it, but I mean, I might be able to break it if I really wanted to with just my hand power, but it would really take a lot of effort. And this is carbon fiber PLA. So the carbon fiber might, give or take, a little bit increase the strength. It did warp a little bit on one side, one corner, so on my next print I'm probably going to do a brim just to try and hold that down a little better. I might also need to leave my window to my X1C open a little bit, my door open, so it'll cool off a little faster. I think that has something to do with the warping. I know with PLA you're supposed to leave the door open, but I didn't. So other than that, I mean, this thing is stout. It's going to work pretty well. There's my light. So in terms of dimensional accuracy, it works pretty perfectly. Something I didn't think about is I probably don't want that whole stem right there to be the same diameter. That way it'll actually stop. It'll have a positive stop, I guess a positive stop. So that bolt will go directly in the middle or close to the middle. So otherwise, if you go too far, it's really on the thick part. I'm also going to edit the sketch so that, whoops, sorry, so that this diameter is not as small. It doesn't have to be that small. One thing about looking at your current piece that you're trying to model is, yes, I made this one almost exactly this. Oh, no, I didn't. Huh. I don't know what I did there, but that diameter is not the same. This is quite a bit thinner than that diameter. What did I do there? We'll look at that when we get back to the software. Really, I could have the entire diameter be this diameter here, which is just going to make it one stronger, and it's going to do less damage to this when I actually go to tighten that bolt down on the plastic and give it just a bigger diameter to grip against. I did tighten it down a time or two. You can actually see where it sort of embossed the plastic just from the pressure. So I want to be doing that on a wider, more firm diameter part than that thin part right there. I'm still going to use this one, but for future ones that I print, because I'm going to have at least 2 or 3 of those lights hung up around here for different views. So I'm going to print at least 1 or 2 more of these, and maybe some more for my wife and her videography. But let's go jump back into the program, and I'm going to make a few edits to this. Okay, so now that we are back, let's take another look at that main diameter. So I have a diameter on the measurement of about 11.5. Is that what I actually wrote? Yes, that is actually what I wrote. That is a diameter. Sometimes in the CNC program, diameters and radiuses, radii, get mixed up because there's a button to click to select which one. But this is definitely a radius, and that's why, let's see, 4.25. Actually, I don't think I'd actually dimensioned that. And that'll do it. That will do it. So I'm going to remove this because we don't need that dimension there. I do want this to be able to come down. So what is locking that? I want this line to come down further. Ah, duh. It's this thing that I just made. Let's delete that. Let's pull this down here. So we want that to be 11.5. So let's click D, click that line, then that line. Let's do 11.5 divided by 2, and that is much larger than what it was. So I forgot to put that one in there, and that's why it's so thin. This should be much better. I had dimensioned something that caused it to be that. I dimensioned that distance, but that distance was way off. I've got 13 here, and what do you know? I've got 13 on my drawing. I don't know what I did. That's what happens. We make mistakes. We're going to go with that. We're going to select. Finish the edit. Okay, and then that, because we built everything off of that first
2D draft right there, the 2D sketch, it automatically updated the physical part. So as long as you go back to your original sketch and make a change there, it'll update everything later on. As long as there's not the problem that arises in other things that you've done since then, it should work out just fine. A lot of times it does. Sometimes you'll have to go back and tweak some other features and different things that you've done down here. But now we've got that larger. That's essentially exactly what we have on the part that I started with. So that's what we're going to go with. Okay, so here we go. Got it loaded up. Make sure to change the filament type. PLA-CF. Got the thicker thing there. That's good. Let's go ahead and add some brim. Where's brim again? All right, there we go. Not skirt. Brim. Let's do outer and inner, I guess. Brim width. Let's see what that looks like. Yeah, that's probably good. 5mm brim width on the inside and outside. Keep all the parts from raising, even though it was only like part over here or something like that. All right, that looks good to me. All of our changes have been made. Print that plate. Turn off auto bed leveling. Keep the flow dynamics, I guess. Send. Yes, I know they're brittle. Confirm. All right.
Okay, so now we have that newest piece completed, and wow, I mean, it's crazy what a little bit of a brim can do. Not sure if you can see that here in the video. The lighting's not great, which is why I'm doing this project, to get the lighting better. You can see maybe that this one's just pulled up quite a bit. Nowhere else on the part, but just right there. It's pretty substantial. Print quality doesn't look great. Absolutely perfect print quality with the brim. Now, it does make it a little bit harder to scrape all that stuff off. So that's a little bit more work you have to do, but it's not that bad. And there's special tools to sort of help just shave all that off. I just used a pocket knife, just scrape the side there a little bit, and then it is good to go. We got that thicker diameter there, so it should be perfectly good to go. All right. And of course, I forgot to thicken this up too, just so that it wouldn't go too far in, but that really doesn't matter. It's still going to work exactly like it should. The real question is how tight can I really wrench down on that thing? And I mean, it's holding up the weight that direction. Let's see. Yeah, you can kind of see a little bit of a, again, you probably can't see that, but leaves a little bit of a mark. We could have printed something like a tiny little cylinder with a part of it cut out of the side to slide in there so that it can still, so it can still cinch down on this, and then it would just mark that part, but I don't really think it's going to matter that much if there's a little mark on this thing. So, without further ado, let's go ahead and screw this thing into the wall. Okay, so I have looked at the orientation that I want for this mount, and it turns out that if I do it pointing that thing this direction, I'm going to have more control over how my light can flex or change angle on its bracket. So that's the orientation I'm going to do. Then also, don't forget to use your handy dandy stud finder. This is a Franklin Sensors one. Franklin Sensors doesn't say the model name on it. I thought it did. Nope, it doesn't. Alright. I'll see if I can look that up and tell you which one it is, but so I could go just directly into the corner. Typically there's always a stud there. Okay, so I've marked out the spot where my first screw is going to go. I also highly recommend getting a very long screw just to make sure you get all the way in to where you need to. I'll go ahead and put that screw all the way through the hole just to make it a little bit easier on myself. Okay, we've got success. Okay, now I've got a lot more overhead light. All right, now look at that. A lot more light. Not exactly sure that's the color light I'm going for. I wanted more of a white, like LED color. Don't exactly know the color temperature. I may look it up and put it on the screen, but that's just a basic decent amount of light. You can always change the light balance and not change the light bulb. I'm probably going to change the light bulb, so that'll make it a lot easier. But that's the first one I'm going to put up. I'm going to put a second one up. Haven't exactly decided where. Probably like right back there, because I'm getting a lot of light on this side of my face. Want more on this side as well, so I light everything up. And then I'll probably have a singular mobile one that I can put up just to get more front-facing light. Yeah, but let me see if I can put that other one up and wrap this video up. Okay, so here we are with both of them installed. Show you a quick picture just so you can see sort of how they're mounted and everything. This is with all the brightness power that these two can offer. There's 4 bulbs in each. There's 2 switches, so you can turn 2 on, 2 off, and so on. So I've got 8 total bulbs right now. These are 100-watt equivalent LED bulbs. So there's a lot of light power coming through right now. These are, what were they, 1600 lumen bulbs each. So got a whole lot more lumens coming in now. I much more so like this color. Hopefully it's coming through well on the camera. I may need to adjust my white balance, which I may do before I post the video. I don't know yet. So I wanted to point out these bulbs. I mean, lighting technology over the past 10 years has just gone through the roof. I mean, this is crazy. So I was clearly, wanted specific color range, temperature, whatever you want to call it, for my room, you know, more of the whitish, bright LED look instead of that like golden sepia toned kind of light. Didn't want that. Just for projects like this and for just illuminating everything really well, I think that whitish light lights things up better. So these bulbs, saw at Home Depot, while not cheap, although they weren't necessarily more expensive than any of the other lights, but lighting nowadays is, everything's getting expensive as all get out. But for specifically wanting to be able to have a certain color, this was just about the best, cheapest option. These have actual 6 different lighting color temperatures that you can easily switch by just rotating the base down here. It goes from 2700 to 3000, 3500, 4000, 5000, and 6500K. And that's just awesome. You know, so I have 2 in this side at 6500, 2 in that side at 6500, and then 2 at 4000 to try and give a little bit more warmth maybe, and I'll probably mess with that here soon just to see what all my options are, because there's a whole bunch of different options I have with that many levels that I can change. And I've got a third light set, which I don't exactly know what I'm gonna do with that one. I kind of want top-down light, which might be more helpful over there once I get this desk over there and my other desk here in the future. But for when I do overhead projects, like with circuitry and things like that, you know, I want everything to be very well lit. So I don't know exactly what I'm going to do with that third one which is another 4 lights. So like $55–$60 later after the lights, I finally have a better light. And hopefully it looks better for y'all. That was just a quick run through on how to make a product to fit your needs. We're going to run into problems every single day in so many different ways, especially when you do just a whole bunch of different things, different hobbies. You're going to have a whole bunch of different problems. So if you don't already have a 3D printer, I highly suggest getting one. Highly suggest Bamboo Lab. They do not sponsor me. I wish they did, maybe in the future. I absolutely love my X1C. It does everything I want it to. I don't think I've had a single, maybe 1 or 2 very minor problems with it that were very easy to fix. There's so much documentation online. The A1 Mini is like very affordable, and I think maybe now $300 or so. They're always having sales, so watch for those. But wow, just yeah, get a 3D printer. If you already have one, I hope that this helped you. If you don't know much about 3D modeling, or if you even do, hopefully you learned a quick tip or trick. But I want to thank you all for checking out this video, and stay tuned for more.